In Module 4, I will explain the naming of alkanes to you. Now, IUPAC is just an abbreviation that we use for the International Union of Pure and Applied Chemistry. And the nomenclature is just a set of basic rules that we use when we name the organic molecules. These rules are compiled by the International Union of Pure and Applied Chemistry, and in this presentation I will only cover a few basic rules that are applicable to the work that we do in grade 12. In Module 3, I taught you about the stem of the name in organic chemistry. So the stem of the name indicates to us the number of carbon atoms in the molecule. The last part of the name indicates to us to which homologous series this molecule belongs to. And you have learned about substituents. So the first part of the name will indicate to us which substituents are part of the molecule and their positions. To name an organic molecule, you just have to follow the rules. The first rule is you have to find the longest continuous chain of carbon atoms in the molecule. And this means that you might have to include branches in the longest continuous chain. So in our example here, if you start from the left and you go all the way to the right, the amount of carbons in the chain will be 5. If you start at the bottom and you go all the way to the top, the amount of carbons will be 4. If you start at the bottom and you go all the way to the right, there will also be 5 carbons in the chain. So the longest possible chain in this molecule will be 5 carbons. And it doesn't matter if you choose this one as your longest chain or the one around the corner. You will end up with the same name. So choose one of the longest continuous carbon chains as the longest chain in your molecule. So the stem for this molecule will be pent, because pent refers to 5 carbons in the longest chain of this molecule. And because we know that there are only single bonds between all the carbons in the molecule, we know that this will be an alkane. So the last part of the name must be an ANE to indicate to us that the homologous series of this molecule is an alkane. The second rule: number the carbon atoms in the main chain to give the lowest numbers to the alkyl groups or the substituents. So we can agree that there are 5 carbons in the longest chain, and one way of numbering these carbons would be to start on the right hand side and follow through to the left. So it's 1, 2, 3, 4 and 5. But the rule says that we have to give the lowest numbers to the alkyl groups. And here you can see that the alkyl groups or branches are on number 3 and 4. But if we rather number the carbons from left to right, you can see that this changes to 2 and 3. And because the combination of 2 and 3 is lower than the combination of 3 and 4, we rather number this carbon chain from left to right. Rule number 3. Identify and number all the substituents. So there's 1 carbon in this substituent or alkyl group, which makes it a methyl, and this methyl has a bond to carbon number 2. And then you can see that this is also a methyl substituent, and this methyl has a bond with carbon number 3. So there's a methyl at 2 and a methyl at 3. And then rule 4. If there are more than 1 identical substituent, use di, tri, and tetra to represent the amount of substituents. So the methyl at 2 and the methyl at 3 can be changed to dimethyl at 2, 3. Finally, we are ready to write down the name of this molecule. The stem for this name will be pent. The last part of the name will be ane. and the first part of the name will be dimethyl. So the only thing left to do now is to show where the two methyls are, and we know that they are on carbons number 2 and number 3, so we write it as 2, 3 and then a hyphen dimethylpentane. Just something to remember, if there are two different alkyl groups present, they are written in alphabetical order. You ignore the di and the tri for the alphabetical order, but you do include them for the name of the molecule. The name of this molecule is 3-ethyl-2,3-dimethylhexane. So how did I get to this name? The longest carbon chain that I can find will be 6 carbons, and you can see that we number these carbons from left to right because the combination of the substituents numbers from left to right will be 2, 3, 3. If you number these carbons from the right to the left, this combination will be 4, 4, 5. So rather number them from left to right so that you have these substituents on the lowest numbers. Then we know that there are 2 methyl substituents, each with 1 carbon in it, and they are on number 2 and 3, and 1 ethyl substituent on number 3. So alphabetical order for methyl and ethyl, ethyl comes before methyl, and therefore we write down 3-ethyl and then 2,3. There are 2 methyls, dimethyl, hexane, hex for the 6 carbons, and it's an alkane. So the name of this molecule then is 3-ethyl-2,3-dimethylhexane. In a name we use hyphens to separate numbers and letters, and we use commas to separate two numbers. You always write the name as a single word with no spaces. In grade 12 there are 2 homologous series where we do use 2 words for the name, but I will remind you when we get to those homologous series. Nomenclature for the ring structures is not part of the CAP syllabus, but I just want to mention that cyclo in a name is for ring structures. And I mention this because you will come across some of the ring structures in the prescribed practical for this topic. Now these are basic rules for the alkanes, and we will add to these rules when we get to the specific homologous series. But these 4 rules are sufficient for the naming of the alkanes. So let's name a few alkanes. The first one is given to you in a condensed structural formula. Now if it's difficult for you to see what this molecule looks like, just redraw this molecule as a structural formula. And now it's easy to see what this molecule looks like. First rule, find the longest carbon chain. The longest carbon chain here is 4 carbons. This is an alkane because there are only single bonds between these carbons. The second rule is to number the carbons to have the lowest numbers on the alkyl groups or the substituents. But there are no substituents, so the third and the fourth rule are also irrelevant. And then we have a name for our molecule. The stem name is bute, and the N tells us that it's an alkane. So the name of this molecule is butane. We use a mixture of butane and propane gas to cook food. The second molecule. So our first rule is to find the longest carbon chain. 3 carbons, so the stem name will be prop. There are only single bonds between the carbons, so this is an alkane. Then the second rule. We have to number the carbons to have the lowest number on the alkyl groups. Now there's only one alkyl group, which is a methyl because there's only 1 carbon in this alkyl group. So the alkyl group is on number 2. It doesn't matter if we number these carbons left to right or right to left, the alkyl group will be on carbon number 2. So we know the name of this molecule then will be 2-methyl propane. Now pause the video and try to write down the name of this molecule before I give you the name. The longest chain is 3 carbons, so the stem name is prop. There are only single bonds between the carbons, so this is an alkane. If we number these carbons from left to right, both of these alkyl groups are on carbon number 2. But if we number it from right to left, you will see that these two alkyl groups are still on carbon number 2. So it doesn't matter from which side we number this specific molecule. Now we name these alkyl groups. In both of these alkyl groups, there is only one carbon in the alkyl group, so then it's a methyl. So we have a methyl at carbon 2 and another methyl at carbon 2. So the name for this molecule then is 2,2-dimethyl propane. One word. The di tells us that there are 2 methyls. Where are they? They are both on number 2. So we separate the two numbers with a comma, and we separate the numbers and the letters with a hyphen. The longest chain is 5 carbons, so the stem name will be pent. Only single bonds, so this is an alkane. If we number the longest chain from the bottom, the alkyl group is on carbon number 3. But if we number it from the right hand side, the alkyl group will still be on carbon number 3. So it doesn't matter. The alkyl group is a methyl, and this methyl is on carbon number 3. So the name for this molecule is then 3-methyl pentane. A hyphen to separate the number from the letter, and one word. The longest carbon chain will be 4 carbons, so the stem name is bute. It's an alkane because there are only single bonds between the carbons. If we number the longest chain from left to right, both of these alkyl groups will be on carbon number 2. If we number the carbon chain from right to left, both of these alkyl groups will be on carbon number 3. So 2,2 is lower than 3,3, and that is why we rather number the longest chain from left to right to have both of these alkyl groups on a lower combination of numbers. Both of these alkyl groups are methyls, so we have a methyl on carbon number 2 and a methyl on carbon number 2, and then the name for this molecule is 2,2-dimethyl butane. A comma between the two numbers and a hyphen between the number and the letter, and the name is only one word. Now this molecule has a catch. Pause the video and try to see if you can write down the name of this molecule. Here is the catch. There are 2 carbons in C2H5, and they are both part of the longest carbon chain. So the longest carbon chain here is 5 carbons, and then the stem name is pent. There are only single bonds between the carbons, so this is an alkane. I start to number the carbons on the right hand side because a combination for the alkyl groups of 2, 3, 3 is lower compared to the combination of 3, 3, 4. That would have been the combination if I started at the bottom. There are only methyl groups, so there are 3 of them, a methyl on carbon number 2, another methyl on carbon number 3, and a last methyl on carbon number 3. So the name for this molecule then will be 2,33-trimethyl pentane. Commas between the numbers, a hyphen between the number and the letter, a try to indicate that there are 3 methyls, and then one word for the name. The longest carbon chain here will be 6 carbons, so the stem name is hex. only single bonds between all the carbons, and if you're not sure, draw the structural formula for this molecule, and that is an alkane. Only one alkyl group. If I start to number at the bottom right, this alkyl group will be on carbon number 1, 2, 3. If I start to number at the top right, this alkyl group will be on carbon number 4. So I rather start at the bottom. So it's carbon number 1, 2, 3. So there's a methyl at carbon number 3. And the name for this molecule then will be 3-methyl hexane. A hyphen between the number and the letter, and one word for the name. This molecule is given to you as a condensed structural formula, but it's just easier to write down the name of this molecule if you can see the structure. So we redraw this molecule in its structural formula. Alkyl groups are given to us in brackets, so it's just easier to draw the structure by starting with a carbon outside of the brackets. So we start with this carbon. It has a bond with 1 hydrogen, this carbon 2 hydrogens, and the last carbon 3 hydrogens. Then we go back to the brackets. There are 2 of these methyl groups, and both of them have bonds with this carbon. So we have to draw a methyl group from this carbon and another methyl group from this carbon. And then we just make sure that each one of these carbons have 4 bonds. And this molecule is easy to name. The longest carbon chain, 4 carbons, so the stem name is bute. There are only single bonds, so it's an alkane. And if we number from top to bottom, the alkyl group will be on carbon number 2. If we number from bottom to top, it will be on carbon number 3. So we will number from top to bottom to have this substituent or alkyl group on carbon number 2. And the name then for this alkyl group is a methyl. So there's a methyl at carbon 2, and the name for the molecule then is 2-methyl butane. Hyphen between the number and the letter, and one word for the name. Draw a structural formula for the following organic compound, 2-methyl butane. Alright, so you press pause and then you try first before I give you the answer. The stem name, bute, so there are only 4 carbons in the longest carbon chain. On the second carbon, there must be a methyl. So you draw a methyl group on the second carbon, and it's an alkane. So all the carbons must have only single bonds between the carbons and hydrogens. And you have to draw 4 bonds on each carbon. Your turn again. Try 4-ethyl heptane. The stem name is hept, so there are 7 carbons in the longest carbon chain. On carbon number 4, there must be an ethyl. So you draw an ethyl on the 4th carbon, and then this is an alkane again, so there are only single bonds between all the carbons, and you make sure that each one of these carbons have 4 bonds with other atoms. The structural molecule for 2-methylbutane is shown below. Draw 2 structural isomers for this molecule and name these isomers. If you can't remember isomers, please refer back to the second module where we explained what the different types of isomers are. Isomers are molecules with the same molecular formula but different structures. So the molecular formula here will be 5 carbons and 12 hydrogens. So the molecular formula is C5H12. Now one way to get an isomer will be to change the position of the alkyl group. But is this actually an isomer of the first molecule? The name of the first molecule is 2-methylbutane, because we number the longest chain of carbons from right to left, and the methyl is then on carbon number 2. But if we name this molecule, we will number the carbon chain from left to right, and then the methyl will still be on carbon number 2. So this is definitely not an isomer of the first molecule because it still has the same name. I show this to you because it's a common mistake. Always check the isomer that you draw to see if it's got a different name. If not, it's not an isomer. So we still have to draw two isomers of C5H12. Now, one way will be to have a single carbon chain with 5 carbons in it. So if you have 5 carbons, there are still 12 hydrogens. This will be a chain isomer of the first molecule, and we call this one pentane. And we can again change the chain and have 3 carbons in the longest chain with 2 methyls. And you will see that there are still 5 carbons and 12 hydrogens. And the name for this one then will be 2,2-dimethyl propane. If you are an educator that would like to inquire about the use of these PowerPoint slideshows in your classroom, you may contact me at lawsandwonders@gmail.com. Please indicate if this topic was useful to you or not, and subscribe to my YouTube channel in order to stay informed about the release of my most recent videos.